Hello, my AutoCAD programming peeps. Now I'm going to explain to you all about AutoCAD dictionaries. Now, AutoCAD dictionaries are non-graphical entities which can store any kind of information in any hierarchy. They can make your program smart, like our example program, Architectural Windows. Now I've created some code, some example code to demonstrate how to use AutoCAD dictionaries. So let's go here up to the top. Also, I should explain to you that um, how the AutoCAD dictionaries are separated into two parts, basically. Right? There's a part that stores actual data called LData for some reason, and it can be whatever data you want, just like there can be any data in an AutoCAD list, and they're separated by keys. It's sort of like the uh, output of the intget command. You got a code and then the data associated with that code. Unlike entity DXF, doesn't have to be a number. It can be any string, basically, any alphanumeric string at very least. And so there can be as many keys as you want to it. And the other section of the AutoCAD dictionary is where you store other AutoCAD dictionaries, nested dictionaries. That's what gives AutoCAD dictionaries their ability to store data in a hierarchical fashion. You can attach these dictionaries to entities, but I'm not a big fan of that. I like to attach the objects, the dictionaries, into something called the named object dictionary, which is sort of like the root dictionary of the current drawing. And you can get the entity name of that root dictionary with this command here. It's not a command, it's a function rather. Named object dict. And here I'll execute it right now, and it comes back with an entity name, and that's the named object dict. And the functions that you use to access these dictionaries is VLX LData put, which puts information into a dictionary with a key. VLX LData get, which you use with the key to get that stored information. And then there's VLX LData list, which will return all the data in that particular dictionary in the form of an association list. It'll be a list of keys and then the associated data, just like the output of the entget command. Now, in order for to manipulate the dictionary section, you can add a dictionary with the dictadd command. You can cycle through the dictionary just like the entnext command does for the model space in that current drawing. Or you can use a dict search command with a key to get a particular sub-dictionary. And you can remove dictionaries out of that particular dictionary with the dict remove command. And also the way you create a dictionary is with this funny command right here. Okay. So without further ado, I'm going to create a circle int with this command right here. I'll move this over here so we can see what's going on. So execute that command, and sure enough, the circle shows up right there. I'm going to get the entity name, put in circle int. There's the entity name of the circle. Here's the DXF of the circle right there. I'm clicking Control-Shift-E in order to load these individual lines in in the Visual Lisp IDE right now. And I'm going to get the circle handle with this command. It's 2EF. Now what a handle is, in case you don't know, it is a unique identifier for the entity, but unlike the entity name, it is persistent. It doesn't change from drawing session to drawing session. As you can see, it's stored in the DXF code 5 in the entity data. And once again, so whereas the entity name will change from session to session, the entity handle will not. It is persistent. If you save the drawing, close it, and then reopen it, the entity name will change, as we will demonstrate, but the handle will not. And I use these handles in order to associate information with particular entities. Like, for example, I will store the entity handles of the frames of the windows and the glass of the windows by using their entity handles inside of dictionary entries. So I know what entities are part of what windows, which entities are a part of which windows, rather. So now we're going to make a dictionary with this command here, int make x, blah, blah, blah. And there's the handle. And you can see the data that defines it with this information, this function right here. But the important thing about this entity is that you can store data in it. I'm going to put Carla's number in it. She's a beautiful girl. But that's not a real number, so don't call that number. I don't want a whole lot of autolisp programmers calling up some innocent person in New York City. And so now you can store any kind of data in this dictionary. We'll store a list in key vect1. We'll store the entity name. Oh, hold on. We'll call it, no, I don't want to change it. We'll just call it int1. All right. And so that has stored this entity handle. I'm sorry, this entity name in the key int1. We'll store that entity's handle under the int1 handle key. And we'll store some unnecessary data with this key name right here. Now, in order to get at that information, I really should show you that first. You use the VLAX LData list function to get what's in key Carla. You do that. To get what's in key int1, there's that entity name. To get what's in key int1 handle, you do that. And so as you can see, you can store any kind of data in these dictionaries. Now, in order to get all the data out at once, you can use the VLX LData list command, and it gets you an association list of the keys and their associated information. Vec1 is that. It's just like an association list, exactly like an association list. And then you can use CDR ASOC to get that information out of a variable that you set to the output of VLAX LData list. I think I'm going to show you that real quick. Hold on, I'm going to set up some code. Oh, hold on, can I do that right now? Is it going to stop recording?